All right, we're doing over 4.1 exponential functions preparation. All right, so let's just start with some examples. This should be a review. But let's say we have a 4 to the negative second power over 5 to the negative third power. To get rid of these negative exponents, if you want to simplify these, you have to get rid of the negative exponents. You're going to switch the position. So if you have a negative exponent in the numerator, you're going to simply put it on the denominator. And if you have a negative exponent in the denominator, you're simply going to put it in the numerator. So in this case, since you have a negative exponent in both the numerator and the denominator, you're simply going to switch the numerator and denominator. Now, whenever you switch the positions, you want to switch the sign of the exponent. So this used to be a 5 to the negative third power in the bottom, and now it's 5 to the positive third power in the top. Okay, and we have a 4 to the negative second power on the top, so we're going to rewrite that on the bottom, and it's going to turn into 4 to the positive second power on the bottom. Now this answer right here is an exponential notation, but if we don't want it in exponential notation, we're actually going to have to multiply this out, and that's 5 times 5 times 5. So 5 times 5 is 25, times 5 is 125, so we would simply write 125, and then we would put that on the bottom, and this right here is 4 to the second power. 4 times 4 is 16. So you'd simply end up with 125 over 16. All right. Now, second situation is the same, except now instead of dealing with numbers, now we're going to deal with variables, okay? But the same exact concept applies. So if it has a negative exponent, it's in the numerator, we're going to put it in the denominator. And if it's a negative exponent in the denominator, we're going to put it in the numerator. Okay, so in this case, again, we're just going to flip it. So we end up with p to the first power on top, but we don't really even need to write a 1 there. I'll write a 1 there just to make it a little more clear, but again, it's not necessary. It's an implied or understood 1 exponent when you don't see one. And on the bottom, we're going to say it's m to the positive fifth power. Okay, now in this case, there's really not much you can do. You just probably don't want to write that 1 exponent whenever you enter your answers into my math lab. So you probably just want to leave it off. Okay, let's move on to the next one. Now, the first two examples, you only had one factor on the top or the bottom in the numerator or the denominator, okay? But sometimes you'll have more than one. Now, the key here is to realize that you're only going to move or manipulate the factors with negative exponents in this case, right? So a to the negative second power, as you see right here, has a negative exponent. Now, you might think this somehow shares this negative 2 exponent, but it doesn't. Because you actually don't see the exponent, you actually know this exponent is a 1. It has an implied or understood 1 exponent, which is positive, which means we don't manipulate it, we don't move that at all. That just stays in the numerator. Now the a to the negative second exponent is actually going to go down to the denominator. Now, on the bottom we have a 3d to the negative third power. Now just like the numerator, the a to the negative second power, the d here has a negative 3 exponent. Okay, so we're going to move that. We're going to move that to the numerator. We're going to move that up. Now the 3 here, it actually has a 1, a positive 1 exponent. Now because it has a positive 1 exponent, we're not going to move it. We're going to leave that the same. Okay, so all we're moving is the a to the negative second and the d to the negative 3. Okay, so let's see what we get here. So we kept the b to the first power, right? And now we're going to move the d to the positive third now power onto the top. Now we're going to keep the 3, but now we're going to move the a to the positive second power, right? Now at this point, since nothing cancels out, there's no variables, nothing's going to cancel out in the numerator and the denominator, right? No like factors, right? We have a b, a d on the top, and we have a 3 and an a on the bottom, so there's nothing going to cancel out. So this is actually our simplified answer. Now I move on to the next one. Now this one's a little bit different. Now, I'm going to explain this 2 different ways. If you look at the top, there's a couple of ways to do this. The way you normally do is you use this form right here, where if I have an entire fraction within parentheses to a negative exponent, we simply flip the fraction, and then we make the exponent positive. But I'm going to add in an extra step here, just to kind of show you that this rule should kind of make sense. And this is what I mean by that. Let's say instead we just distribute, and it's not really distribution, but it kind of looks like it. We simply attach this negative 4 exponent to both the top and the bottom. It's going to hit every one of the factors in the top and the bottom. So we would end up with an x to the negative 4 over 2 to the negative 4 y to the negative 4. Now, what would immediately happen after this? Well, because now that everything has a negative exponent, you're going to move everything. You're going to move this x to the negative 4th power to the bottom, right? And you're going to move both 2 to the negative 4th power and y to the negative 4 power to the top. Okay? And then what you would end up with is 2 to the positive 4th power, y to the positive 4th power, over x to the positive 4th power. Okay, now, and so you actually end up switching the numerator and the denominator eventually anyways, even if you kind of just skip that positive rules right here, this one right here. You can actually just skip that trick and do it the long way. But since we know that's going to happen anyways, that we're going to actually switch the position of the numerator and the denominator, we might as well just do it with the fraction. All in one step, right? So let's see, just rewrite it really quickly. So say we have an x over 2y to the negative 4th power. Well, 2y over x to the positive 4th power. And then if we distribute this, right, and again, it's not technically distribution, but it kind of looks like it. If we put it on every one of the factors in the numerator and the denominator, we actually end up with exactly the same answer. And that's not an accident. As long as you use these exponent rules correctly, there oftentimes are multiple ways of doing the same exact thing, right? Get the exact right answer or simplify it using a multitude of these different exponent rules, right? As long as you use them correctly, eventually, usually you'll end up at the correct answer. Even if it takes you an extra step or two, you can eventually get the correct answer. Now, we're not quite done here because even though this is the correct answer exponentially, right, in exponent form, we can further simplify this. For instance, 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So if we wanted to simplify this further, we could simply write it that 2 to the 4th power. Instead, we could write that as a 16, right? Instead of a 2 to the 4th power. There we go, right? Okay, now let's go ahead and try to evaluate some of these other expressions, right? So let's say we're just going to use the same trick we just learned, right? Just a couple of extra practice problems. So in this case, we're going to switch it to over 1. But now instead of it being 1/2 to the negative 4th power, we switch 2 over 1 to the positive 4th power. Now before we actually kind of distribute this inside, or kind of looks like that, 2 divided by 1, remember we're doing PEMDAS, so order of operations kind of dictates that we could simplify within the parentheses first. So 2 divided by 1 is simply 2, so we'll simply end up with, you don't really need this parenthesis, but I'll put it anyways, you'll end up with 2 to the 4th power, which is just like the previous problem, is still 16. Okay, so let's try this one. Now in this case, we're saying 3 over 7 to the negative 2nd power. Well, again, we'll flip it, so now it's 7 over 3 to the positive 2nd power. And now we just attach it to both the numerator and the denominator, so we end up with 7 to the 2nd over 3 to the 2nd, and that gives me 49 over 9. Now, nothing's going to cancel. Now, you can see in the factored form that it wasn't going to cancel anyways. We have 7s in the numerator. We have 3s in the denominator. There's no like factors in the numerator and the denominator to cancel. And, of course, there's no greatest common factor between 49 and 9 except 1, so this is in simplified form as a fraction. So we'll move on to the next one. Same kind of concept. We have a fraction within parentheses to a negative power. So we simply flip it. This is going to be 5 over 4 to the positive 3rd power. So now we're going to bring 5 to the positive 3rd power over 4 to the positive 3rd power. Now, 5 to the 3rd power is simply 125. And 4 to the 3rd power, 4 times 4 is 16, and 16 times 4 is 64. So we just leave it like that, right? 125 over 64. And again, just like the previous examples, if we look here, nothing's going to cancel out. We have 5 to the 3rd power, we have 5's in the numerator, and we have 4 to the 3rd power, 4's in the denominator, so nothing's the same. And also, even after we simplify or get rid of the exponents. There's no greatest common factor between 125 and 64 except for 1, so this fraction is simplified. Okay.